Hello.
Hey,
Morning, or whatever time of day it is for you.
getting late afternoon.
Hi, everybody. I'll just rejoin with the SIG account so that I can enable screen sharing for everyone. All right, we have a packed agenda, so let's get started. Hi, Jeremy. So welcome everybody to the July 1st SIG multi-cluster call. And so the first topic is in the scrub decision to merge PR 5436 and enhancements. Let me just share my screen. All right. Yeah, so I think this one's good to go. It's about the conflict requirements. It was discussed in last week's call, I think. Yeah, so essentially, it's about this part here. We're allowing implementations to only set the conflict, well, if they want to only set the conflict on the specific service import that introduces the conflict. So the idea here is you have multiple service exports on different clusters for the same service, and they create conflicts. Where do we report that conflict? And initially, they required it to be reported everywhere, but that's difficult for some implementations. Jeremy.
So yeah, kind of going back to, we discussed this approach a couple of years ago, I think. The problem is that I don't think you can identify consistently who introduced the conflict. Like what the reason why we went with timestamp as an ugly but effective resolution is it's hard to say in a distributed system which is the odd one out. like I could conceivably add a couple service exports to a multi-cluster service that make the existing service that in a cluster that was never touched now the one that is violating our expectations. So it'd be weird to only put the air condition on that one service.
Yeah, we discussed this last week. I think everybody was
Right.
fine with this. Laura was, but I understand what you're saying, but it's not feasible. What if you can't do that?
I mean,
It's not
so if,
really realistically feasible unless you jump through a lot of weird hoops to try to communicate information about every service export.
so then I would make the whole
So I
thing a
don't know what you want me to
recommendation.
do here. I'm not sure what you want implementation to do if it's not feasible for them to do that.
So the thing is we've adjusted, like if we're going to have a recommendation to have a conflict declaration, that's fine. But it seems like what we've done is change the, like previously the requirement was to do it in a way that was ugly but effective. If we're going to soften the requirement, because it's not feasible in all implementations, that's okay. But now we're like the at a minimum is, I would remove that. But maybe the whole like, well, let me ask this, like, is it feasible to resolve based on creation timestamp at all?
Yeah, I was able to do that, but again, I had to go through some hoops. I had to put the creation timestamp of every service export communicated by as an annotation on the exported
Right,
service import, which is kind of ugly, but
right. But
so
but if you can do that, then can't you add the, I mean, I agree that it's ugly, but if you can do that, can't you add the conflict label to all of those service exports?
conflict label.
Or the condition?
Well, condition isn't really conducive because you need a condition per importing cluster or exporting, I should say. So a single condition with a well-known type, unless you append it all to the message string, reduce some more ugliness there.
Right.
It's just, I mean, unless we want to add more fields to the cluster condition, cluster status, so that, well, if that's intended for, I assume it's intended for exporting clusters to fill in, the first, it has cluster name right now. So,
Right.
so I'm using that to say, here's all the clusters that are exporting the service. So perhaps if that has more information as to what the contributing information, local information for each, excuse me, cluster, like its type that it's seeing, and its ports and all this other information. You have to duplicate all it.
So-
Theoretically, the affinity config if you want to, do conflicts on that and whatever else. So then, yeah, then each cluster, I was able to do the ports and put it on every one because we communicate the ports by the endpoint slices have the ports contributed
Right.
by every cluster. So we're already distributing that. So the ports was feasible to do. But the rest of these, again, I'd have to communicate to every other cluster what's my observed service type, what's my observed session config, or my observed whatever other fields it are that we could conflict on. So that's what kind of makes it difficult and to do.
Well, as suggested right now, are you able to set a condition on the service export that introduced the conflict?
Yeah. Well, right. Because what I do is I basically have a shared aggregated service import that each cluster contributes to that's on a hub cluster. So they're able to see, oh, it's already there. And I can see the timestamp. I can see what the oldest timestamp was. I'm not the oldest timestamp. So therefore, if a new cluster is now exporting, see, it's already exported. I got a timestamp of the previous cluster. I'm older, but my type conflicts. Then I'm able to just on my local service export, I can stick that condition on there. The conflict condition. So that's how I've been able to do it.
Okay.
But yeah. Anyway, no, I get what you're saying. Ideally, you do want to set it on all of them. For the arguments you make. Right now we do use timestamp. Well, recommend in the cap as a way to detect or to resolve conflicts. Whether or not that's the best way to do it, that's the way it's defined right now. Therefore, you can theoretically you could say, well, conflicting cluster is one that came in after that doesn't have the oldest timestamp. So
Right.
that's kind
And
of how I've done it. But
and that all makes sense, except that like if this is the result of a gradual rollout, or I'm making an update and I make a change to a cluster, then yeah, this behavior makes absolute, as described in the update, makes absolute sense. Where it gets confusing is if I'm like using like a CI pipeline to push changes to a bunch of clusters at once, and everything is in my mind in parallel, and there's an error. Then
right.
it gets then time is a lot less meaningful.
Yeah, it's ambiguous as to who's the one who should be the winner, really, in that
Right.
scenario. Yeah,
And
I
so you need to look
totally
at
get
every
that.
cluster to understand. That's trying
Yeah.
to avoid. So if there was a way to like, even if it was like a two-step thing where you see once the service export has a condition, maybe that gets passed on to that aggregated service view as like a label or an annotation that you can then extrapolate. Like I'm wondering if there's a way to kind of fan it out without having to do a ton of really, really ugly external bookkeeping, which I agree we would like to avoid.
I mean, theoretically, sure, you could put extra metadata on these shared service imports to say, okay, here's my cluster, here's my type, or here's my session, But then you gotta, I mean, type is easy because it's a simple string, but when you have other fields that are not simple strings, you have to kind of munge that into in an annotation value or something like and
Yeah,
parsing and all that kind of stuff, which again, it's ugliness. I just don't want to do this.
it is ugly.
Avoid.
And I hate saying this, but there's a long history of JSON annotations in Kubernetes. But um, Arthur, you had a good comment as well. Like, could it be just at a minimum all the service exports that disagree with the resolve state? And I kind of going back to this to start again. What we really just wanted to avoid is a situation where you have to look at every single cluster exporting a service to understand that there's a problem. And because disagree, and because there's no authoritative way to say in this multi-party contributor system which cluster is actually the source of truth. Anything that doesn't show, hey, there's a problem on all clusters, means that I have to be tracking all clusters to know if there's a problem anywhere. And we were trying to avoid that. Maybe we don't need to avoid that, but that was the motivation. It's like, as
I
someone
totally
who's,
agree.
yeah,
I agree with the motivation. I agree with the idea behind it. It's just, unless you have a central controller that has access to all the clusters information at once, and that's making a decision like that. It's, do we want to require that of an implementation? I wouldn't think so. Put that, requirement on there. I mean,
yeah. Well, I mean, we should not require a centralized controller, but like I think we just talked about some ways that are, like, I agree, not super clean, but effective. Like if a service export following this, you know, let's say we start with anyone who disagrees with the resolve state shows the condition. Well, once I show the condition on a service export, couldn't I then just copy that
Propagate
condition to
that.
the authoritative, like whatever the current consensus version is that's being fanned out, and then have all the other exports basically note, hey, I picked up this condition somewhere in the cluster.
Of course, but there's no, again, it comes down to a clean way to do it. I mean, unless perhaps we can, like I kind of proposed, is could we extend the cluster status information further instead of just a cluster name? Allow us to put in the contributing information for each cluster, not just its name, but what its other service related information is, so that you could say, here's what I think it is, here's my data, here's cluster 1, here's cluster 2 data, and then yeah, certainly I could make that, and that would be watch for updates and all that. And I'm doing that with the ports because like, again, every cluster distributes its endpoint slices. So, and luckily the endpoint slices have the ports.
Right.
So yeah, it's exactly what I'm doing. I'm able to collaborate all that information to figure out that there's a conflict. And then every cluster running its own control can then put the condition on the service export. But that's the only information I have distributed right now. It's being done through another mechanism, not the service import. So, I mean, yeah, perhaps, to be another, I could push a proposal or PR or whatever to add some more, fields to the cluster status information, whatever we call it, whether it ends up under status or not, whatever it is, it's the cluster status field, whatever, structure. It's already struck, so I think it just has cluster name. So,
right. I mean, that to me sounds pretty reasonable. Yeah, that sounds much more reasonable. And like, I've been talking a lot, so I'd love to hear what other folks think. But to me, it's like, really, it seems if we're gonna have the conflict case, which I think we do want to be able to show that there's a conflict somewhere, then we should figure out like what are the core principles. Like, is it as important as we thought it was a while ago that you don't have to look at all the clusters? Is it important that I think if we have it, it has to be consistent across implementations in the way you use it. Otherwise it gets really tricky to understand how you actually consume this service. So like, we wouldn't want an implementation where sometimes you can look at one cluster and sometimes you have to look at all clusters. If the answer is that we just need more metadata, so that because we haven't done a good job setting this up for fully distributed implementations without a centralized controller, then let's fix that for sure.
Okay. All right. That's cool. I can do that.
Or I'm totally wrong and other folks should speak up too.
Well, that's true.
Yeah.
Talking, so.
Yeah, I'm going to call time though, because this is only supposed to be the scrub. But yeah, Jeremy, if you don't mind adding your comments to the PR. Arthur, I liked your idea as well, and Tom, follow up with what you suggested.
What was Arthur's idea? Oh, it's in the chat. Sorry, I wasn't looking.
Yeah, that is to require that all service exports that disagree with the resolve state be updated instead of just the one that introduced, because there is no introducing a conflict anyway. Well, we can't figure that out. Anyway,
to be honest, I think that's what you meant. It's just like a sentencing. Well, anyway.
Yeah, probably. But it's better if it's clearer. And I also think it's worth at the very least making it explicit in the KEP what the constraints are, if we do end up with a sort of compromise in this, what the important thing, what the things that we care about are, and what the constraints are in relation to, well, we're choosing time, but time isn't necessarily all that meaningful, that sort of thing. And that we don't want to end up with re-implementing a raft, as John is mentioning. But anyway, please take the discussion to the PR.
Yep. And one last thing I just want to say on that too is, like, if we come up that there is no good consistent way to make this behave, then one outcome is also to just not have that behavior. Like, if we can't make it consistent, not having it's better than having it inconsistent is kind of my view.
Yeah. I'll write that down because that's important.
Yeah, and it's all came about just while Steve was typing. Because of my PR, I added a performance test to check for service type conflicts and make sure that there's a conflict condition put on the service export. And I did it on again for it to succeed in submariners, end to end GitHub Action Suite. I just checked for the export condition, or the condition on the second service export that conflicted. So that's where all this came about. And so if we want to enforce this, again, the question is, I know in the capital it says put it on all the service exports. So that's one thing. And then obviously, ideally, if we're going to require that, then the performance test should do the same. I should make sure you put it on all the service exports. But then we run into this issue: is you have an implementation that where it's kind of problematic to do that, or without going through some weird hoops to do it. That was that's where the discussion originated from. All right, well, I'll wait your comments on that, and then we'll take it from there. I can push a proposal, capital, or maybe just a PR, I don't know, just to add additional fields to the service export to reflect each cluster's service information, and we can go take it from there as well. And perhaps we don't need any change to the cap. We can keep it the way it is.
Yeah, that would be great.
Anyway, okay, sorry, Stephen.
And Mike's got his hand raised as well.
Oh, for me, the performance question is
your audio is really bad.
Is that any better?
Yeah.
Okay. Yeah, just for me, it's less a question of performance considerations and more of like, this feels like something that is a reasonable kind of RBAC like permission structure of some implementations don't have the ability to write to resources in other clusters in the kind of decentralized model. So it feels like a valid thing to solve for in some way.
Yeah. Yeah, that is a good point. Thanks. Right, so moving on. Content asked about KEP 5339, and so that's essentially just up to Jeremy and me to review. So I've added it to my priority list. And the same goes for the property ladder and the placement decision API. So that's for Jeremy and me.
For the property
Save
ladder
homework.
too, I didn't, sorry, can you hear me? Whoop.
Yeah.
Yeah, for the property ladder, I didn't copy over the comments that we discussed in the meeting, that I like took some notes in like comments in this doc, and I didn't like move them over to the PR. So I'm going to do that too. And then I'll ping you guys so that you know that everything is in context of that like PR instead of like fragmented.
In the notes. Right. Thanks. Okay. Yeah, and so onto the topics then. The first one was added to the scrub, but I think it's really a topic.
Yeah.
So I'm not sure it's the first one in the order, but I'll, it was floated a while back. So MJ, I guess it's you.
Yeah, it's basically three of us. I think Marvin and Stefan are on the call. So let me try to share a screen. Someone else is sharing.
Yeah, I'm
Oh.
still sharing. So usually it just crashes on me when I try to stop. So let's see.
I will try to be relatively quick so we can have more time for discussion. So while I still,
Yeah, that's not going to work.
so we're gonna sort this out. We've been working on this project, which was started long time ago by Stefan, and there is a multiple KubeCon talks and other conferences talks about this. And we're looking for a way to make it more community accessible, basically part of the CNCF ecosystem in a way. And I would like to give a short demo and introduction to the project and basically measure a room temperature to see if there is enough interest in this becoming something more official. So we can basically potentially move homes of the project and make it more CNCF type governed. So let's get the intros out of the room. Can you see my screen?
I don't.
Silence?
I don't personally.
No.
Yeah.
Oh wait, something's happening.
Can you retry? We were seeing Stefan.
Yeah.
Yeah,
Better
okay.
now?
Now we
Zoom.
see.
Yeah.
Okay. And wrong window. Zoom, why you can't do simple things? Now, full screen should be visible, right?
Yes, full screen is visible.
Cool. So the project is QBind. We have a web page, QBind.io. The Git repository is QBind dedicated organization. Similarly as previous one, multi-cluster runtime, it's most of the thing is done based on a CNCF template, but it's still independent organization. So what's QBind is basically, and there is a YouTube talk, I'm gonna share that later on. So first of all, what is trying to solve? So we are here now at something 2025. We're basically dealing with many clusters and we're sorting out many clusters problems. But at the same time, we've been looking how we can create a cross-cluster standard for communication. Basically, design a post-cluster technology in a way, open framework where anybody can become a service provider persona, basically, and operate the services in a more central way when it's done now using operators. So what we're targeting is open specification for a backend, client, and authentication methods to allow X as a service behavior between semi-trusted parties. And I'm gonna show you how this is, what's currently is there and where we're looking to evolve this thing. So what's under the hood, basically, you have a cluster which acts as a service provider. And it's basically upstream up. And what you have is you have many consumers, so potentially other Kubernetes clusters. So in an old world, if you want to have a database operator installed, you have to install it in every clusters. What we're proposing is to create a standard between these parties where operator would be installed on the one cluster and it acts as a service provider. So CRDs are managed by central party and the objects, instances of these objects would be synced up and down, potentially secrets managed by. So in a way, managed service provider pattern between the clusters. How does this looks like? And I'm gonna show a demo in a second is, as a consumer, there is a standard way of standard defined like protocol which at a high level does like what services you have. It returns a list of services and credentials, and you express intent to bind a service. And you have a standardized agent, which basically takes over the management of this. And both parties and consumers basically have to trust a centralized IDP of some sort. So that's very high level. I cut a lot of content out because I think demo speaks 1,000 words than slides. So what I have here, I have a GKE cluster, which has a single backend deployed in that cluster. Means this backend is a kubebind backend. This means this cluster is intended to be used as a provider. And I have a CRD installed MongoDB cluster, MongoDB basically. So let's check this out. So if I check MongoDB is currently instantiated in the cluster, I have a bunch of them in a different namespaces and in different names. Let's have another cluster called John. Kind creates cluster. Okay, it will be Bob. So I will have a fresh cluster basically, which wants to consume MongoDB instances as a database. But if I check CRDs, I don't have anything. So as a consumer, what I do, I call to well-known URL, which is exposed by this backend URL, basically. Another thing which is running here is IDP, so DEX is running in a cluster. So you say kubectl bind, exports, it gives you a URL. As a consumer, you open the URL, and it says very crude backend. Says like, I have these services available to consume it. What you didn't saw is because it's a SSO handshake, it got redirected to GitHub, trusted, and got redirected back. So the SSO handshake happened already. So if I basically, come on, if I do this, okay, let's, for the sake of time, skip it. So what I do, I said bind, basically authentication, and CLI got redirected and things happening. So let's give it a second. So, and let's start watching our database instance on a provider cluster. So what's happening now, I got installed one of the CRDs, which is intended for the service provider to track state, and the CRD got pulled. So what happened under the hood, agent got deployed, standardized agent, and it pulled this CRD based on a handshake. So now as a user, I can start consuming the services same way as I would be using normally local installed operator. So let's create a database, and we see what happens is that instance gets synced into the provider cluster. So if I get out, it's created, it's nothing happening. So just to show how this kind of would be working. So because the object now landed in a provider cluster, we assume that there would be an operator running in a provider cluster which would act on this object and implement it. By implementing, I mean going to some database as a service, creating a database, updating the object. So let's say which swapping the state to running. And once the provider updates the local instance of that CRD with a credential, potentially like secret reference or some other metadata, this gets synced back to the consumer cluster. And there is a protections that based on what I showed in the slides, what you can do is basically from the consumer side, you sync spec down and the status goes basically you sync spec one way, you sync status other way, and in the future potentially other resources. So where we are now, we have a example backend done. So this is what you saw, allowing bind arbitrary CRDs to consumer. We have a high level contract definition in a way, service API service export, which allows to define what you want to bind. We have certain things planned in the future where we want to extend it to have more permission granularity, include the related resources, like label selectors, write some more. The agent itself currently is in a quite good state client side. The backend UI, as you've seen, is a bit crude and might need some love. So this is the current state, and quite a few of us are investing time in this, but I think we're looking for a more like a different governance model closer to SNCF, so it becomes more official in a way. And with this, any questions?
If I can maybe just add one more thing to what Em showed, like from the multi-cluster runtime and KCP perspective, we talk a lot about services, but I know that I think the SIG talks about services in a bit different way. So this isn't targeting the same abstraction layer as MCS. We're not talking about Kubernetes services on the network layer. We're talking basically about sharing custom resource APIs across cluster boundaries, to put it very simply. Just so it's not. I think there's some overlap in the ideas, but MCS is targeting something different. Just so to clarify that.
Naming is hard. So I see some raised hands. Arthur? I'm not sure who was first.
Yeah, your project sounds interesting. I have few questions. Does the how much do you need to adapt a potential controller to make it multi-cluster with Combine? Is it any specific? And secondly, how does it work when the controller actually want to schedule pods, things like that? Is it only if you are calling a provider to schedule your MongoDB or something crossplane
And please correct me, Stefan, Marvin, if you have I don't think there is any appetite to go into scheduling itself. We have already quite a lot of projects out there dealing with a scheduling of things. From the operator's perspective, your first question, it's some of the operators already can do that and work in this pattern. We did a workshop in London KubeCon where we picked up Postgres CNCF operator, and we've proven that this pattern works without zero changes in the code. Because in the end, it's just a CRD transformation and copying between provider and consumer. It's more to enable this void in the middle. How does consumer cluster talks to the provider and provider talks to the consumer in a standardized way?
Okay, so for instance, with the Postgres operator, that would be a way to create a Postgres cluster on the provider cluster. But then how can you connect to it and stuff like that?
So think of this more in our organizations usually, then you have a database as a service team, team which owns all databases.
Yeah.
Only in rare cases you basically deploy databases in your own 10 clusters you have. What you have, you go somewhere, you ask for database,
right?
And what you get a connection string and password. So this would enable things like that, where your consumer clusters can create a CRD in the same way how we do with a cross-plane example. And now the CRD gets synced to the database as a service team cluster. They provision the cluster in their own environments, and you get the required details to access it. So it doesn't.
Okay, I see.
It doesn't
And
do the.
This is assuming that you have a shared network and things like that, and you can access like Postgres in the provider cluster. Okay, right. Okay.
So we don't look to solve these particular like problems again, networking or like share stuff. Again, there is a many projects. It's more to establish the open standard of this consumer provider communication in a way.
Mm-hmm. Okay, I see that. Thanks for answering. That looks interesting to me. And I know Mike has questioned.
Yeah, and I think that you tried to speak to this earlier when you were talking about like managing CRDs across multiple clusters, but I guess like one of the things that immediately jumps out to me is I'm kind of curious to what extent this intersects or overlaps with patterns like deploying multi-cluster service meshes for like the auth n, auth z bits and things like that. Because obviously like that's out of the scope of MCS. That's just MCS is just service discovery. But that I guess that's what I'm trying to figure out is this a thing that you expect or want service meshes to implement? Is this solving a different problem?
No, I think it's solving a total different problem. Like I don't see almost any overlap. It's more like
it's about the spec, the CID defining the existence of a service. Like imagine you have your cluster and you deploy your application. So you have Argo CD running against your cluster and you have deployments and everything else, all the objects you want, but now you need the database. So you get the database API from the database team via this mechanism. And then you declare, I want this MongoDB database who or production or something. And then this custom resource is synced to the database team, they provision, and you can connect.
so it's
an ordering interface if you want. It's not the data layer, it's purely specification. So basically the control plane layer.
Maybe is a little bit similar to some of the stuff with like the very distant over in like WebAssembly component model and like defining the capabilities that your application requires.
Yeah.
Like, this is the way to fulfill them.
But natively deep in the API stack of Kube. So you get CIDs. That's the interface, nothing else.
Oh.
And you get a secret which has the credentials when you create a database.
So it's the same way like in the current world, if you want a database and you're building something like a hack project on a stuff, where do you go to get a database? You're going to one of those 100 SaaS providers which can give you managed Postgres. It's like I'm not gonna drop names. Or you need managed Kubernetes. You go to to certain clouds. We don't have any pattern in Kubernetes how to create something as a service. Like our as a service by default always ends up, you install operator in a cluster and it does the things for you. And this would solve, you don't install like one operator to this every cluster. You install it once and you sync the objects out. In a way would be like certificate provisioning, imagining. Most of the organizations, they have a centralized CA, which they protect, they guard, and they don't want to distribute for certificate creation. So in this way, your cert manager type of object lives in every consumer cluster. It gets synced to the central cluster, which has a CA, certificates gets created, and it's synced back. So I think it's like
a similar analogy. There are tools like Crossplane, or there's ACK in AWS, and Google has a similar thing, like those controllers which have CRDs for the cloud services. And those are usually manually built by development teams in the cloud providers. Now you are on site and you want, for your platform, you want to have the same thing. So you have services in different clusters, different organizations, and you want to publish them as CRDs in other clusters and consume them. But you don't want to run the pods. Like when I get a database from, the Google service database, like whatever it is, Postgres, I will not see it running, right? I only see the object defining it locally. So it's for platform builders who want to create a similar experience as ACK or Crossplane or something like that, which is CRD based.
Yeah, it's a Arthur, to your question. It's like it's all CRDs. The CLI is just a developer experience.
But like do you have a way without invoking the CLI and without clicking on anything? Oh,
like
okay.
you still need to establish like CLI helps to establish the trust, like exchange the OEDC, exchange the credentials. But if you have this trust established, means in a simple layman's term, you have a kube config from provider, which was given to you. Everything else can be GitOps established. The CLI is only for OEDC in most cases to do that web browser handshake.
Okay, cool. Sounds interesting then. Well, it sounds interesting even without that.
Ilya?
Yes. Maybe just to sum up what I understood. So essentially, it's a way for us to submit CRs instances to target cluster, which will instantiate database and sync the relevant metadata back into the consumer cluster. My question is, what is the fidelity between CRDs, which are in the target cluster and in the provisioning cluster? And angle is that, as you mentioned in your example today, you have to go to some other cluster to initiate provisioning. They give you secret and you go to your cluster. What you do in return, however, is that you don't have this CRD dependency. For example, you can go to different providers, use different instances or versions of Postgres or so forth, and you don't have kind of lock-in at the CRD level, in the sense that once you install that CRD of that version, then you kind of stuck with it. So if some other application or team in your cluster would like to use other version of the database, they probably pretty much need to stick with what currently being affinitized to. Sorry if I'm rambling, but that's kind of my angle on the question.
But that's the same if you have an operator, right? If you install a Postgres operator, you will also be logged in. So it's the same thing. If the operator, or in our case, the CRDs are from a different vendor, the group will be different. So you can, of course, have multiple versions of them.
I agree. In case if option is between me installing an operator locally or me deferring that operator to some other cluster, totally, it's the same case. What I'm looking more in terms of like if we using service as a service database where I don't have to kind of sync CRD back, or perhaps CRD could be more nuanced where you can say, yeah, it's not high fidelity. It's almost the same as in the target cluster, but it gives you options to parameterize in, but with this version of and so forth.
So, yeah, I mean, this goes into the territory of enabling the operators, right? If you have an operator controller, those CRDs must support versioning, right? In some way, like a Postgres version, for example.
Right.
Yeah, it all goes to going to the more familiar, like you could use cross-plane composition and sync only the CRD of the composition, basically. And implementation details are left to the owning team, basically, at the provider side. So it's, in the end, you can write your own CRD, which has only database true, false, and sync that in and out. What happens on the provider side, how it's getting realized, it's up to you. And this is non-opinionated way. Like, the idea is you establish the syncing pattern, not what you sync, basically.
the backend can be an operator, it can be cross-chain, it can be Crow, it can be anything else. It's basically completely agnostic what implements the CIDs on the backend side.
Makes sense. It also just to point out that in terms of like when you install operator locally, and let's say if you do have some incompatibility of different versions, you will deal with it at install time, right? Here we're dealing it at the provisioning time, in sense like hypothetically you have two different backends which serve different versions, which could be incompatible. I know, I'm sorry, I'm going maybe to rabbit hole, but yeah.
It makes sense, but like I've been in my previous experience been working in environments where you have hundreds of clusters. So having 5 backends with 5 versions is way better than having hundreds clusters with 100 versions. So it's a question of management and how we want to span it. Again, this doesn't put any opinions on that. This says if you want to use this pattern, you can have 2 backends exposing, or even same backend exposing 2 versions. The backend currently is just a spec. One could write a one backend which points to the multiple clusters, like spans in and out. Cool. So
Yeah, that makes sense. Thank you for answering.
Yeah, and thanks, Mike, for the time check.
yeah. So the question is there? I can hear that like there is an interest of that. Like it's still it's a topic I think which not it's been explored a lot, but I don't think we have anything standardized yet. And the question is like, is there appetite in SIG multicluster to try to work together basically with us to try to define the standard?
Just what do you mean by standard? Like you mean common APIs or you mean project?
It's a common APIs and potential example implementations. But I would see it in a similar way how we have a cluster spec. Basically, it would be a common APIs, example backends, which one could already picked up and use, and the like vendor neutral agent part of this, like it's more, yeah, it's a standard, like open spec basically.
Right. Okay. Yeah. So, well, in the interest of time, I suggest we revisit this next week. MJ, could you add links to the slides in the agenda doc? And I invite people who are interested in this to take a look at the project again. And Mike's adding some notes. So yeah, so Mike's taking notes, but then it's your topic next, or Arthur or Tom, about standardizing service export condition types and reasons.
Who gets to talk about that? I don't know. I mean, you can share the PR maybe. I don't have it open though, but if someone has open, you can share screen.
Yeah, someone can share screen with.
I can do it. Please hold.
While that's coming up, I can kind of intro a background here. Is we're trying to kind of tighten up some of the service export conditions, knowing that that's like the primary interface. This is somewhat came out of the initial investigation into conformance stuff, but trying to get these closer and more consistent and also more comprehensive in describing like the set of conditions that could lead to conflicts, and giving standardized reasons and types for how this should be displayed in a conditions field. And then the next one is doing a single case just for service import for something that cannot be expressed at export time.
Sorry, did I show these in the wrong order? So this is the first thing you're talking about?
Yeah.
The first one is the cap change, and then this is the
Oh, okay. Oh, okay, okay, okay.
Yeah.
Well, I mean, the caption is like this. Primarily the is this isn't the right caption though?
Oh, sorry. Yeah, oops.
Yes.
There's two things in parallel that we've been working on over the past week.
Oh,
One is for service export, and there's
sorry.
and one is for service import. And I think I just dropped the wrong link in there. So,
I sent the link in the chat.
Okay, okay, okay.
It is.
All right, people. There we go. Something's happening.
Sorry, it was unclear who was presenting this, so we should have.
We're just gonna go to these random links you send me in chat. It's very safe. Please send me a mysterious QR code and I'll definitely go to that.
Yeah, so yeah, this is it. If you open it, here we had a bunch of like standardized condition and stuff like that. Oh, wait. Yeah, this is the cap.
This is correct. Okay, cool, cool, cool. So we're talking about this. Yes, it's exportable.
Yeah, so
I see.
yeah, basically before, I think those were kind of defined like before the condition types was even a thing. So we are trying to do an overhaul of everything and kind of aligning of gateway API things that made some good work and we can copy from essentially.
Yeah, the original ones, I think the like meta v1 condition like did not exist in Kubernetes at the time. So
Yeah,
this was very much a like proto version of that and defining their own types. And yeah, based on basically like a lot of what Gateway API has kind of evolved over the past like 2 to 3 years in terms of really trying to like tighten up and formalize some of this and finding either prior art or similar patterns to the extent possible was the goal here.
And in the other pair, you have like all the condition that we standardize. Well, we want to standardize at least.
Okay, sorry, possibly dumb question, but okay, so I'm getting that like these were in the prior version of, or like the early version, I guess, of conditions, we would have to like define basically our own types, and then that is what we would include down here. I think you're saying that there's now like some sort of centralized defined types and or prior art in other APIs. I'm not sure which of those two, like what level of.
It's more prior art.
Okay, more prior art. Okay. And then
But-
Gateway API team has already kind of like standardized around some of that prior art. And then this would be
yeah, maybe open
absorbing the prior
other
art.
Yeah, maybe open the other peer about
Okay.
like.
Yeah,
I'm gonna
because
need you
that
to
has
send me a link.
link.
Or is it like, oh, this one?
The one on MCS API.
Oh, okay,
I
this
can
one.
send it.
I think it's in the OP.
The 112.
Yeah, it's this one, exactly.
Okay. All right. Sorry,
No.
not my link foo is not super powerful today, but yes.
No, it's our fault.
Okay.
So yeah, if you scroll down a bit, like this deprecate the old one. And then here you have all the conditions. So first one is accepted, bunch of reason. Then exported, and then some conflict things.
Okay, yep.
So we tried to basically like articulate what are the possible like known failure states that are implementation neutral. These are because the reasons field is a string on meta v1 condition. this is something that is extendable by implementations. If you have some like implementation specific failure case, that's definitely possible to like write your own. But this is the kind of the set that we thought was common to most implementations and worth adding to the actual Go types themselves.
Okay. Cool.
So an implementation could theoretically like import this and then be able to just like set the actual standardized types, and it also kind of makes conformance easier because you can test for like kind of known scenarios of like if a port is defined differently, then like what's the behavior.
Gotcha.
And I guess we will talk about the rest like next week probably.
Yeah, I do think we ran out of time. So, Stephen, do you want to
we have indeed.
take over?
Yeah. So yeah.
But please, like check the cap if you are into MCS and
Okay. Yeah.
thinking about conditions.
So
definitely.
looking for comments on this cap and then this other PR, which is the implementation specifically for MCS of the ideas updated in this cap PR is what I'm getting.
Just a note, because like the type is getting big, we also the idea is to get those details out of the cap and make it more into MCS API.
Got it. Okay. Yeah.
And Arthur, Tom, and myself have all taken a look at this and the service import one.
Okay. Cool.
All right. Well, yes, there's a bunch of stuff left over for next week. Thanks everybody for attending and participating. Have a good rest of the week. I'll see some of you on Thursday for the APAC friendly call.
Okay, yeah.
And the rest of you next week.
See ya.
Bye.
Yeah.